All right, let's dive right into a cosmic mystery happening in our very own backyard. It's a classic whodunit, really, but the crime is a case of missing spin, and the victim is our sun. So picture the birth of our solar system, right? A huge, swirling cloud of gas and dust. Now, you know how an ice skater pulls in their arms to spin faster and faster? It's the same principle. As that cloud collapsed, all that material, most of which became the sun, should have been spinning like crazy. So the sun should have almost all of that original spin, but it doesn't, not even close. Okay, let's look at the evidence. Mass-wise, the sun is the undisputed heavyweight champion of the solar system, holding 99.8% of everything. No surprise there. But look at angular momentum. That's the spin. The sun is a total lightweight. All that momentum is out there with the planets, and Jupiter's got pretty much the whole bag. So how is that even possible? To figure this out, we've got to treat this like a real detective story. First, let's survey the scene of the crime and get a handle on just how strange this situation really is. Let's put some numbers on this, because it is wild. Jupiter, which is just a tiny speck compared to the sun, has about 20 times more angular momentum. It's a complete and total mismatch. You have this massive body at the center that's barely turning, while a relatively tiny planet is zipping around holding all the rotational energy. This just flies in the face of how we think solar systems are supposed to form.
And here's the real kicker for astronomers. It's not just some weird quirk of our solar system. When we look out into the cosmos at young stars, stars that are a lot like our sun was in its youth, we see them spinning way, way faster. That tells us something huge. Our sun must have been a speed demon back in the day, and something, somewhere along the line, slammed on the brakes.
So, if something slowed the sun down, we need a prime suspect. And the most obvious one, suspect number one, is a force that's been streaming away from the sun for eons, the solar wind.
The logic here seems pretty straightforward, doesn't it? The sun is constantly blowing off these tiny charged particles. As they fly away, they should, in theory, carry a little bit of the sun's spin with them. So the big question is, could this gentle cosmic breeze, over billions of years, really be enough to slow down an entire star?
Well, scientists did the math, and the answer they got was a big, resounding no way. Not even in the same ballpark. For the solar wind to do this all by itself, it would take, get this, 40 trillion years. Our entire solar system is only about 5 billion years old. So yeah, that theory is a bust. The solar wind can't be working alone. But what if our prime suspect had an accomplice? A powerful, invisible partner in crime that boosted its effect by thousands of times. Now this is where the mystery really starts to get interesting. You see, as those charged particles stream away from the sun, they don't just fly into empty space. They have to pass through another immense, invisible force field, one that stretches deep into the solar system, shaping everything it touches. And that is the secret accomplice, the sun's magnetic field. It's the key to the whole mystery. Think about it. The magnetic field is locked to the sun's rotation. So as these solar wind particles try to escape, this magnetic field latches onto them, forcing them to keep spinning with the sun long after they've left the actual surface. It's like our ice skater again, but this time they're extending their arms way out while holding heavy weights. The slowdown effect is absolutely massive. Now, there's a technical name for this giant magnetic lever. It's called the Alfvén radius. Basically, you can think of it as a huge bubble around the sun. Inside that bubble, any charged particle is forced to spin right along with the star. Once it crosses that boundary, it's finally free. So, just how big is this invisible sphere of influence? It's gigantic. It extends out to about 140 times the sun's actual radius. To put that in perspective, a particle is still magnetically locked to the sun's spin when it's already more than halfway to the orbit of Mercury. This just massively, massively amplifies the amount of momentum each particle carries away with it. Okay, so we've got our suspect, the solar wind, and we've identified its powerful accomplice, the magnetic field. It's time to put all the pieces together and crack this case wide open. So the crucial point is how it all goes down. Step 1, particles escape the sun. Step 2, the magnetic field grabs them and slings them around, forcing them to spin with the sun over a huge distance. And step 3, that single action amplifies the spin they carry away by a factor of nearly 20,000. It's what turns a gentle breeze into an incredibly powerful cosmic break.
And just look at this stunning result.
Remember that impossible number, 40 trillion years? Well, once you factor in that magnetic field acting as a lever, the timescale drops all the way down to about 2 billion years. Suddenly, the math fits perfectly within the sun's lifetime. The accomplice wasn't just helpful, it was the key to the whole thing.
So we've solved the case for our sun. But why does this one puzzle matter in the grand scheme of things? Well, because it gives us a vital clue for understanding how stars evolve all across the universe.
We started with a simple question. Why is our sun spinning so slowly? And the answer is just so elegant. The sun didn't just passively lose its spin, it actively threw it away over billions of years, using its own magnetic field as a giant slingshot. It's an incredibly efficient, self-regulating braking system.
And that leaves us with one last, really big thought. This entire cosmic drama, this whole mystery, was driven by a force that's completely invisible to us. And if our own star used this invisible field to totally reshape its own destiny, well, it just makes you wonder, right? What other profound secrets about how planets are born, how stars live, and how entire galaxies evolve are still out there, hiding in plain sight within the magnetic fields that weave through our universe?